Good morning, good afternoon, good evening. Welcome to a special edition of the Data Services Office Hour. I am Chris Short, host with the most of Red Hat live streaming. I'm joined by one of my favorite Red Hatters and an Intel person. Yay! Thank you, Ryan and Audrey, for coming on today. Audrey, you want to tee up what we're talking about today a little bit?
Yeah, for sure. We're
Please introduce
looking
yourself too.
at,
I'm sorry. Yeah,
of
yeah,
course.
rounds of
Sorry.
introductions. It's early. I forget stuff too. So, it's fine.
Oh, yeah, no problem. It is early on the West Coast here, 6 a.m. Yeah, coffee. I need that.
Yes,
Um,
sorry. I'll send you
but
some.
yeah, I got it. No. So today we're looking at how we can tackle AI ML workloads using Red Hat OpenShift, the platform, with OpenVINO, which is a fabulous Intel product. So
Nice.
Ryan and I had actually spoken about this in a session earlier this week, and I thought, well, we need to spread the love. We need to tell everybody about OpenVINO and Red Hat OpenShift.
Awesome. Sounds great.
So, yeah. Now, would you like me to go ahead and speak some more about this?
Let's let Ryan introduce himself. How about that?
Okay.
Well, so yeah, I'm Ryan Loney. I'm a product manager at Intel for the OpenVINO toolkit, which is a set of libraries and tools that are used for optimizing deep learning inference. And we've done a lot of work to integrate with Red Hat so that it's easier to deploy and optimize, quantize these AI models so that they can be deployed in OpenShift and so they can be deployed on Red Hat Enterprise Linux. And we're going to talk a little bit about it today.
Awesome.
Yeah, so one of the things that we found that is pretty prevalent right now in industry, since we have kind of a need for an open hybrid cloud and AI platform, is that around 69% of the enterprises today use a mix of open source and cloud-based software to power their AI initiatives, which is fantastic. So again, that's really the reason that Ryan and myself are here today, because we want to talk about these two products that Red Hat and Intel have created. So cue the intro for Red Hat OpenShift Data Science and cue the intro for Intel OpenVINO. And I did want to mention that, since we have so many enterprises using the open source and cloud-based software to power their AI initiatives, one thing that's also very interesting is, despite the large number of vendors that are out there and cloud platforms, architectures to choose from, most of the technology leaders are using open source tools, which is yay, fabulous.
Yeah.
And it's 78% of them are their initiatives that they've actually gone ahead and created are deployed using hybrid cloud infrastructure. So it makes it a fabulous opportunity for us to get our products out there.
That's awesome. So cool. And the partnership with Intel, how did that even start, right? How did that get going, I guess?
Wow, that's a good one. Ryan, go for it.
Well, for me, I think sometime last year, we started to communicate more directly, at least my team that's building OpenVINO. And I remember it must have been in January of this year, one of the solutions architects, Kyle Bader, he and I were on a call, and I'd never met anyone at Red Hat before. I'd talked to the team inside Intel that worked with Red Hat, and it was sort of like a game of telephone sometimes. You'd hear, okay, Red Hat is doing this, they're going to launch a new data science program. And then I actually got to talk to a solutions architect, and he really explained it so well and said, this is what we're trying to do. It's going to be, leveraging open source tools under the hood, Kubeflow, Open Data Hub. And I had never heard of Open Data Hub before. And after he told me all this and got me really excited, and I said, oh, this is a great idea, you should definitely do it. There's a lot of cloud providers that have these sort of vendor lock-in tools that you can use on their service, but I haven't seen this like managed MLOps, Kubeflow type Open Data Hub offered by anyone else. And I think it'd be great if Red Hat did it. And he said, great, we need you to do something too. So we see that you have a Helm chart and some Kubernetes integration that you have with OpenVINO. Can you turn that into an operator for OpenShift, get it certified, certify some of your containers? We need them to run on UBI. And at that point, we had not done much work with, we had just started to enable and validate our software on Red Hat Enterprise Linux. We had previously supported CentOS and had customers working with other flavors of Linux. So it wasn't too hard to move over, but that's really when it kicked into high gears, when we started taking that Helm chart, turning it into an operator, then turning it into an OpenShift operator, going through the certification, and the partnership has gotten stronger since then.
That's awesome, right? And that's like most partnerships at Red Hat, right? It's like, let's work on a couple bits here, work on a couple bits there, and usually it turns out awesome. So it's great to hear. So do we want to talk about OpenShift and OpenVINO together? I like how they both stay open, like capital letter open in the names. This is pretty cool.
So yeah, I can start on that. What we have with OpenVINO is it is one of our managed services that's available on Rhodes. And what's really cool about it is that when you go ahead and choose it in our Red Hat OpenShift data science platform and spin up a Jupyter notebook, it actually comes prepared with all of these wonderful tutorials. And for one, I love that because I get to go through the tutorials to see how it would work with our Red Hat OpenShift data science product. And I can go into detail in terms of the inferencing and the quantization, but I might let Ryan speak in a bit to describe more maybe about the process that they went through to get OpenVINO actually ready for Red Hat OpenShift data science.
Yeah, would it help if, I don't want to dive right into a demo, but should I share my screen and show the OpenShift console? And
yeah, let's jump right in.
Let's go do that. That would be fantastic.
Cool. So I'm just diving right into our Rhodes cluster, and let me know if you can see.
Yes,
I can
if you
see
could
a screen.
Increase the font size just like 2 ticks maybe. All right, I can read it. So folks, if you can't, let me know, and we'll
can always make it bigger.
Can always make it bigger. Yeah, so please continue. Thank you.
Cool. So I just went over to the installed operators on this managed cluster that we have that Red Hat is managing for us. And we have the pre-release version, I guess I would say, of OpenShift Data Science installed. We have these 2 operators from Intel. One is the AI Analytics Toolkit, and this includes some of the common frameworks created by third parties like TensorFlow, PyTorch, and we sort of bake in our Intel optimization so you can keep using TensorFlow, keep using PyTorch, Modin, Pandas, scikit-learn with some of the low-level MathKit library and optimizations from one API baked in. So, but I'm going to focus on OpenVINO Toolkit, which is our Intel native tool. It's an open source set of tools, like I said before, and runtimes for deep learning inference. And when we did the integration, we were thinking about OpenShift data science and, of course, partnering very close with folks like Audrey. And we added 2 APIs into the operator. One is our existing model server, which is for serving models. It's a service-oriented architecture, so you can it deploys a UBI container, manages it with the operator, and it creates an endpoint for prediction requests for your image classification, object detection, NLP models. And the other is a notebook instance. So all you have to do is click this Create Notebook button, and if you're planning to do development, this will install third-party dependencies that you need in your Jupyter environment so you can run OpenVINO, run tools like TensorFlow, PyTorch, Onyx, and start optimizing the models that you have trained. And we even have some training examples that you can run that also don't require a GPU. So you can just quickly get started doing a training, run it on a Xeon CPU, and start doing some optimization. So when you click Create Notebook, what this does is it pre-installs a bunch of Jupyter notebooks that you can see here that are available through this Jupyter console. And in order to get to this, we'll go to if I'm using Open Data Hub, there's a different link. If I'm using Red Hat OpenShift Data Science, it's just part of the managed services. So I'll go to Red Hat OpenShift Data Science, and then you can see that these cards have been enabled here. So use OpenVINO, one API, and if I launch Jupyter Hub, which I've already done, there'll be an option to just click on OpenVINO, and you can jump right into the notebooks. So I selected the OpenVINO option, launched them, and these are actually 2 Jupyter notebooks that Audrey and I were sharing the other day at an Intel conference. And these are showing how to take a model, train it in TensorFlow. This is sort of like the hello world example that is provided by TensorFlow, and it's the flowers training. So what you're doing is taking, let me see if I can make this larger. And I'll hide this table of contents and put it in presenter mode. Is that a little bit easier to read?
Yeah, that's awesome. Thank you.
Okay. So this is sort of the classic tutorial that TensorFlow provides in open source. It's a image classification model. It's what we would call like a toy model, because you're not really going to just detect 6 or classify 6 types of flowers for many production use cases. But well, I'll dive in and show you what we're doing. So this is the data set that gets downloaded automatically when you launch the Jupyter notebook, and it's going to pull down 3,700 photos of flowers. So there's only 5 subdirectories which for the different classes. So these are the labels that we'll have for when we classify the images, and it's just 5 different types of flowers. And feel free to stop me at any time, Audrey and Chris, if you'd like.
You're doing fabulous. Keep on going.
Yeah, push forward. Like this is cool.
Cool. Yeah. So we take we'll do like a visual inspection just to make sure that our labels are correct. And of course, if you're inputting your own data, this is something you definitely want to do and make sure that the tulips are tulips and the roses are roses. But and then this is just walking through some of the like boilerplate steps that you would have from preparing a TensorFlow image classification training using Keras, which is part of TensorFlow. And you will sometimes see these sort of funny, harmless errors. And often it's either due to you're not using a CUDA, or you're not using some other library that it expects you to use. But these are harmless. So don't be alarmed by the red. And then let's see if again, these are each label, and preparing the data set, some other model preparation, and then we're going to actually run the training on the CPU. And I'll go down to that part so you can see 15 epochs of training. And in this, I don't know how many, I think maybe 14 cores are available to my pod right now. So with this 14 core pod with maybe, I don't know how many gigabytes of memory, not too much, it's able to process each epoch in 152 milliseconds, which is for a CPU. I think it's not too bad. So you have to wait a few minutes for this to run. But again, it's a very simple model. And you can check out inside the notebook and see the accuracy is actually pretty good. It's close to 80% just after running those 15 epochs with those 3,700 flowers. And then this is where we start to hand off between TensorFlow and moving to OpenVINO. So first we're going to download a picture of a sunflower. and make sure that it's classified and see that it works. And so we get this little message down here that says it belongs to sunflowers. We've got 94.86% confidence. Now we're going to save the TensorFlow model, and this is in the saved model format. So often before you take a model to production, you'll save the fully trained model and then use a tool. We have OpenVINO. Some of our competitors have other tools. There's like CoreML, TensorRT, Onyx Runtime, and you'll usually have a step where you convert that to a different format before you deploy it in production. So in this case, we're OpenVINO, so we're going to convert it to the OpenVINO representation. There's a few parameters that can be defined. So the shape of the model, which we know from the previous steps, is 1 by 180, 180 by 3. This is the size of the images. The input images are quite small, and then 3-channel RGB. And so the output type, we're going to go from floating point 32 precision to FP16 when we convert to OpenVINO. So we reduce the size of the model. It's still floating point precision, and we should see no change in accuracy, no change in the output of the model, but the performance should be slightly better. And that's after we run this conversion step. The next thing is, we'll see that it's successful. The next step that we're going to do is to actually use OpenVINO's inference engine to do the inference. So again, we're going to set these 5 classes. We're going to load the OpenVINO optimized version of the model, which you'll actually be able to see. Let me go back to this is the directory that has these 2 notebooks. And we're in the it's quite long, but it's a pretty fun one, getting to see the flowers, and it's easy to visualize, like, okay, what 5 flowers, you got to figure out which one using AI. It's pretty easy to explain what's going on.
Awesome. We're back live, folks. Sorry about that. Zoom just decided to disconnect us from the call. So, yay. Technical difficulties.
So I'll go through like the last few things that we covered. So we did a prediction on the TensorFlow model, and here I'll make this screen a little better. So we saved the TensorFlow model, converted it to the OpenVINO format, and moving to floating point 16. So reducing the model size, a little bit better performance, but no change in there's no noticeable change in the accuracy and the output of the model. And then we're going to run a test, which if you scroll through all of this, you see that the model converts successfully. We're going to load the IR. So the intermediate representation is what we call the OpenVINO format. And when you run that conversion step, you'll see that there's a .bin and a .xml. This is what the output of the OpenVINO format. So there's a binary, and then there's this XML that has a bunch of metadata for the model stored in it. And that's what we're going to use to run the inference in OpenVINO's inference engine. So here we load the network, read it with inference engine, and then we're going to download a picture of a dandelion from Wikipedia, just so we have an image that didn't come from the original training set. And because we don't want to plug in an image that was used during the training, we want to have a totally random one. So we download this dandelion, and we see that it's able to detect or classify it as a dandelion. and with great confidence. And then that brings us to the next step. So the next step is to do quantization. And so now that we've trained the model, it's in OpenVINO format. We see that it's able to classify the image correctly. The next step is to further optimize. So we're going to actually lower the precision to 8 bits. Right now, I said it was in floating point 16. We're going to do a process called quantization. And we have a tool that OpenVINO provides that comes baked into the integration with Red Hat OpenShift Data Science. It's called the Post-Training Optimization tool. And this tutorial, and there's a few others that are currently in the notebook image, and even more that are getting added. I think we have 3 more coming. So it's a lot of examples for you to start with for different use cases. And of course, this is image classification. So first, we're going to just use the model that we trained in the previous notebook. And if you didn't run the previous notebook, this notebook actually checks and downloads and runs the previous notebook if you happen to forget to run the one that does the training. And then there's some sort of, these are steps that are required to run quantization. So with our tool, you have to create a data loader, and there's an accuracy metric to help measure the accuracy to compare the original model with the quantized model. We also have an AccuracyAware algorithm that you can use to set the maximum amount of accuracy drop. So that's some of the reasons for the accuracy metric. And then this is the actual pipeline to use the post-training optimization tool, which performs the post-training quantization. And so this running these steps here, this will give us a compressed model that's in the lower precision, so integer 8 precision, and then it'll save it in the directory. So, I was looking before in the model directory. So now we have this optimized, and these are the low precision models that get saved by running this pipeline. Once you have this bin and this XML, or if you're using a .ONNX and ONNX model, you can take these and deploy them with the model server and create an endpoint in OpenShift so you can serve the models. And I'll talk about that in a minute. But once you've done the experimentation, the work, the quantization, optimization in the notebooks and roads in OpenShift Data Science, you can then download these model artifacts and serve them in OpenShift. But so I'll finish the rest of the notebook before I show what that looks like. One of the most important things that people are always afraid of when using quantization is you are lowering the precision. And one of the key problems that our customers face is the accuracy drops so much that it's not worth the performance gain. So one thing we always want to check is that the original model and the quantized model are roughly the same. And in this case, they're actually almost exactly the same. And there will be cases with more challenging workloads or challenging data sets where you're not able to get this type of accuracy. So you always want to check. And part of the process that we were running before was actually taking some of the images from the original training, using them in the quantization pipeline so we can fine tune this quantized model so that we don't have accuracy drop. And so that's a really important step, is to check the accuracy. And last, we're going to basically do the same thing we did before. We're going to run inference on the quantized model and download that same picture of a dandelion and see what happens. So again, we get the image most likely belongs to dandelion, about the same confidence as before on that one image. And then this is the fun part. So
right.
running the benchmarks. So one of the first things first the benchmark app. This is one of the other tools that we provide in OpenVINO, that once you have an OpenVINO model, you can easily just use this command line tool, or use it through the Jupyter interface to see what the throughput and the latency are for the model that you're using on the hardware that you have. So in this case, we're running this on AWS. We have a Platinum 8259, like a new pretty good Xeon. We don't have access to the full thing because, if I'm using Rhodes and I'm a data scientist, and if everybody requests a pod that's got all the cores, it's gonna be an expensive AWS bill. So this is, I think, with 14 cores, we can see the original model that its throughput is around 2891 frames per second. And then if we look at the quantized model, the integer 8 low precision model, we're getting about 1,000 frames more per second. And so this really matters when you're dealing with like video processing, as one example. If you're processing 30 frames per second or 60 frames per second, getting an extra 1,000 frames without having to buy additional hardware and just not having any drop in accuracy. If I go back up here, I mean, you're getting 1,000 frames more and there's no change here. So that's part of the value that we add with OpenVINO and our tools, and giving you the ability to see the performance in the benchmarks right in the Jupyter notebook. These are not perfectly accurate because there's some overhead with running Jupyter, there's some overhead with Python, but it gives you a rough idea of the increase that you can see by running this quantization step. And then there's also some features that are not going to be available to test when you're running on Rhodes in the cloud on the OpenShift data science. One is that we have Intel GPUs, which right now are just integrated graphics. So like my laptop, I could run this same notebook on my laptop with Fedora, and it actually is able to access the integrated GPU. Or if I had Red Hat Enterprise Linux on a desktop or laptop, or on a NUC, an edge device, you name it, we'd be able to tap into the integrated GPU. And soon, when we launch the discrete graphics cards from Intel, you'll be able to use those as well. And what this does is it's combining both devices. So I can either run it just on the GPU, just on the CPU, or if I do this multi-CPU GPU, it'll maximize the throughput by using both. But of course, on AWS, we don't have integrated GPUs. It's just Xeon scalable processors. So this part you'd have to run locally.
Okay. That's cool. So we have a question in chat here from a friend of the channel, Carlos from IBM. What's the support model for this operator for enterprises wanting to use it? Can they pay Intel for support, patching, that kind of thing? Or how's that relationship work?
Yeah, so we have both a community version that's provided as is without any SLA enterprise support. And then we also have a marketplace offering, so that if you want to use OpenVINO on the OpenShift data science platform, you do need to install the marketplace version, and there is a trial. And so we provide the 24/7 SLA. We have customer support with technical consulting engineers that will provide support to customers who use the marketplace operator. And I believe that so when you install the operator, you will need to install the marketplace version on OpenShift data science. If you want to use Open Data Hub DIY, do it yourself without any support, technical consulting services, then you can use the community version that's on the Red Hat ecosystem catalog.
Awesome. So Carlos, let me know if that doesn't answer your question, but I'm pretty sure that's a comprehensive answer there. So yeah, the benchmarking, anything out of the norm here that you're looking at, or is this expected kind of latency kind of thing? Any bumps in the night you might have noticed using a cloud provider versus local hardware kind of thing?
Yeah, and I think that the key, we don't show a performance benchmark with TensorFlow because it's not really easy to do an apples to apples comparison. But
sure,
I mean, if I did in almost any case, OpenVINO is either slightly or significantly faster, depending on, we do additional optimizations that like operations fusing and pruning of graphs and things that happen by default when you run OpenVINO. And so that you should always expect the performance to be better than just using the framework. And then when it comes to the hardware, I think that getting over 1,000 frames per second for any workload on a CPU that's an accomplishment in itself. I think that oftentimes we have partners, customers who decide to buy expensive discrete graphics cards because they don't think they can get this kind of performance just using their CPU. And so that's, there are cases where you need to get 50,000 frames per second, or, you really want to spend that extra money because you're processing 1,000 camera streams on one server or something like that. But when it comes to using the CPU, it's sort of just a different equation, right? If you have, 88 cores and you know how many frames per second you can process, that determines how many camera streams that pod can process. So you'll have to do the back of the napkin math and say, okay, I can go buy a discrete card and it'll cost me this much per month on AWS, or I can just buy one with Xeon and I can process this many frames, and then decide what's best. But with CPU, the latency here is actually, I think this is great, but it really depends on the workload. So, but
and like all things Kubernetes, it's workload, right? Like, how does your workload perform? What does it want, right? Like, if you have a pod with 100 cores available to it, that might be enough to do your job or whatever you're trying to process there. But
sometimes four
that's
cores
a great
is
point.
enough.
Exactly. That's a great point. That the math is a little different, but sometimes that big expensive GPU, as we're using one right now to produce the show, is worth it, and sometimes it's not, right? So you can save a little money here just by bulking up the CPU, it looks like.
Yeah, and we definitely, especially for training, I mean, I know I showed you this really simple model that's very easy to train. You can train this using a GPU. If you have a GPU instance, train it with an NVIDIA GPU, it'll go much faster. And there's another example that Audrey and I are looking at using for another event that this shows how to do a quantization aware training with PyTorch. And this runs really fast if you use NVIDIA GPU, and then you can of course deploy the inference on Intel hardware, but you can also train it on a CPU. It just takes longer.
Nice. Cool.
Yeah.
That's awesome.
I think I'll just mention here that some people may ask, what industries, may be benefiting from some of this technology. And because I just did a conference session yesterday for IAPG, which is the International Association of Petroleum Geologists, one of the things that comes to mind already, and that I know that Intel is heavily involved with, is looking at seismic. So if you can think of seismic as just basically pictures of the subsurface, but in a way it's almost like an X-ray. You are having a lot of images that you need to process for certain details, certain horizons, or seeing if you can pick out faults, or seeing if you can pick out horizons. And this is where having something like OpenVINO for quantization and for inferencing really makes a big difference, because those industries, or I should say those energy companies, are using state-of-the-art GPUs in their high-performance computing centers, and they're trying to squeeze every last bit of performance out to see what they can see in their subsurface models. And again, I know that Intel has like an open seismic architecture, their alpha release. That's currently a sandbox environment for developers in oil and gas, where they can perform deep learning on 3D and 2D seismic. And for me, that's something that I find fascinating. But don't discount anybody who's doing something in the medical industry, like research for cancers, looking at images. OpenVINO has a lot to offer for a lot of different enterprises and industries.
And I found a link analyzing 3D seismic data using Intel distribution of OpenVINO toolkit. I'm just going to drop that in chat so folks can take a look at that to get a better understanding of that kind of use case.
Yeah, like I said, it's this is really exciting for better,
Yeah,
a better lack of word is it's good stuff that we're really doing together, and I get very excited about this.
Yeah, and I would just add, I would say that I don't know as much about the seismic analysis, but I did a session yesterday with one of our healthcare partners, and similar to the seismic analysis, they have very large input images or input data that goes into the model. So like in the case of X-ray, which we were talking about yesterday, they have like a 1024 by 1024 grayscale image that gets input. They also, they process also like 3D slices of 3D images for CT scans. And they're really measuring not in the frames per second, but they're saying, can we process one frame in less than a second? So it's like a totally different,
That's a paradigm shift. Yeah.
But every little bit of optimization counts when you're dealing with big input like that. So with the X-ray, they were saying, oh, well, we were able to go from 2 seconds with TensorFlow to process one X-ray down to 800 milliseconds with OpenVINO 4 years ago. And then today we're down to 147 milliseconds. So it's like, we keep inching down and going lower. And that was running on an Intel Core processor. So not even a Xeon.
Wow. Okay.
Because they have to plug it into a ultrasound machine and have like a, embedded machine that's next to in the operating room or at the hospital. So there's a lot that we can do to squeeze more performance out of the sort of more low power hardware.
That's fascinating. And just the idea of having that like box next to the X-ray machine, the MRI machine, whatever it may be, like that's incredibly powerful in the hands of the right people, right? Like,
well, yeah, the cost makes a huge difference for, like they were saying around the world, we're lucky in the US, there's like 1 in 10,000, one radiologist for every 10,000 people. But in other parts of the world, it's like 1 for every 250,000 people.
Wow.
And so bringing these devices to places that don't have access to radiologists, and I'm sure with the energy, there's similar challenges of bringing the equipment and doing it on site in places where there's no internet connectivity. You can't connect to AWS when you're, out on a rig, or if you're out on an island somewhere, if you're out somewhere in a hospital that doesn't have, the access to fiber. You just have to run everything right there and do it on a device that is affordable.
Yeah, and I'll just put in a plug for the energy industry. This also helps in the areas where we have data gravity when we're working with national oil companies that don't allow us to take the data out of the country. So what do you do if you can't use, a public cloud provider? You have to create some sort of on-prem or hybrid cloud. And that's where, do you build your own high performance computing center, which could be cost prohibitive, or do you use some of this fancy stuff from Intel? What are you going to do?
We hope you'll use the Intel stuff.
And of course, you're going to use the Intel stuff with Red Hat OpenShift Data Science.
Right. And we're really excited, I think, about the next phase of doing some of this hybrid setup. We're having, edge devices that can be like fleet managed by OpenShift Data Science, where you have control plane in the cloud, and you've got some edge devices that, either call home just to send some telemetry data, or, just to not necessarily sending all the data they're processing back to the cloud. Because I think that's really the future, is we're going to have these low power devices that may not have great internet access, but they need to be managed, right? And they need to be connect back to a control plane like OpenShift.
That's awesome.
Yeah, and I'm just going to put another plug in for the energy industry. That is like freaking amazing, because you have a lot of oil fields that are, not that close to a lot of good cloud services. So we have to do a lot of some of the inferencing on some of the fluids that we're pumping out of the ground or health of the wellhead. We have to do that work away from the mothership, so to speak. So being able to do that, first before we get the rest of the information, makes things so much quicker for the geoscientist or even the engineer who's looking after the oil field, so that he can make decisions quicker, especially if there's something that could be failing, that could be bad. So we want to know about that quicker and not have to chunk through data and a day later say, oh, there's something happening when something bad already happened,
Yeah, just parts wear, right? Like that decreases efficiency, and just knowing that, right? Like knowing that, okay, we're reaching this point where like our coefficient is off and we need to replace a part, then that's incredibly powerful to know that sooner rather than later, right? Like,
especially when you have a couple thousand wellheads in a field,
Exactly. Yeah. You're never gonna be able to inspect that every day unless you have 1,000 people going out to those, because usually oil fields are huge, vast expanses of land.
Yeah. So a lot of good comes out of what we're doing. We're helping people. Yay. It's awesome.
Exactly. That's always awesome. And it's always great to help people. Yeah, exactly. All right. Anything else we want to share here? Or I know we had some slides. Let me drop those in chat, folks, for your benefit, even though we didn't technically use them.
And we also have a intel.com/OpenVINO-customer- OpenVINO-success-stories. And I'll drop that for you, Chris, if you want to
Thank
paste
you.
it.
I was trying to type it as you were saying, and I was like, oh my God.
It's a long one, but
I was good until the second dash, and then you lost me.
So if anyone wants to learn about some of those use cases and hear about the partners like BMW, GE Healthcare, Siemens, and who are solving some of these challenges, and hopefully more of your customers will join this exciting board of success in the future.
Yeah, this is pretty awesome.
And for the oil industry or energy industry, I'm going to drop in the stuff for OpenSeismic because I just think it is freaking awesome what's being done there.
Cool. Let me drop that in chat here for everybody. And yeah, that's awesome stuff. Cool. There's no more questions. If there's no more content, we can wrap here. It's entirely up to y'all how much longer you want to go.
I need coffee, so
okay, yeah. Let's get Ryan some coffee here, folks. Thanks for tuning in. Coming up next at the in 17 minutes, we will have the What's New in OpenShift 4.9 briefing, joined by multiple product managers from the OpenShift team. So please stay tuned for that. And there's a full slate of shows on the calendar today. So please go check out that calendar and join us for any of the shows you might find interesting. Thank you, Audrey. Thank you, Ryan. Really appreciate it. The data science stuff always fascinates me, and this was, again, truly fascinating. So thank you very much for it.
Thanks for having us.
Yeah, thank you.
Stay safe out there, folks. See you soon.